We are honored to have with us Ms. Yukti Suri, Principal Engineer at Ashna Lens. Ms. Yukti Suri is a machine learning and computer vision expert with 10 plus years of experience in the field of extended reality, metaverse, ADAS, and medical robotics. She leads product development related to XR solutions for enterprise, education, and defense sectors. She has 15 plus patents to her name. She is one of the primary co-creators of a complete metaverse program, the Ajna Creator Program. In this session, Ms. Yukti Suri will be presenting on the topic Designing AI Algorithms to Augment Human Capabilities with XR. The session will be followed by a Q&A. I encourage you all to actively engage with the same. Please join me in welcoming Ms. Yukti Suri with a huge round of applause.
Hello. Hello. Namaskaram, everyone. Uh, Thank you for the kind introduction. And before we begin, I'd like to just say that I've had taken a couple of, sessions, talks, some conferences as well. But this is my very first workshop, and I couldn't be happier that it is happening in this institute, which is my alma mater. So, because this is my first workshop, I would like to, uh, you know, need more attention from all of you. So, from the students, because I read what is the difference between conference and workshop, it must include certain exercises, right? So, before we start, may I just ask all of you to just start with a very simple exercise. Just quickly rub your hands. Just warm up your hands and keep it on your eyes. This is a very selfish motivation that you can give me more attention as this is the last session. And after tea and lunch, maybe you guys are feeling a bit less active, right? So I'll start with the topic today. And I love the topic, the theme of this workshop, the design workshop, which is augmented human, right? And this is very much in line with the company that I work with. They also have the same vision. And for us, the vision is augmenting human intelligence. So very much in line with that. So I'll be talking about designing AI algorithms to augment human capabilities with XR. So nothing new. This about me, Yukti Suri. Already a good amount of introduction was given. About Ajna Lens, I'll just give a brief about the company. Named after the sixth chakra, Ajna, or the third eye, as we call it, which is, it is said that with the third eye you can see beyond your normal human vision. And in the physical world that we live in, how can you achieve something like that beyond human vision? That is when you extend the realities, extend your vision with more sensors, with more AI, with more processors. That is the language we speak in, right? So that is what we manifest with these XR devices. And these are all AI-powered XR wearables and immersive learning platforms. That is what we give, not just the headsets, but also the learning platform which we call Ajna Vidya. And why I'm telling you about this is we are the first manufacturers designing also in-house and also manufacturing in India. The first XR headset from India for the world, Ajna XR headset, which achieved quite a lot of awards, but CES Innovation Award back in 2023, and I have the headset with me. I will be showcasing certain demos post workshop if anyone is interested. And also we got the best enterprise solution with Ajna Vidya, which is the learning, training and upskilling platform with XR. So this was all about me and the company, and why I'm telling you about this is that I do have some experience about XR, and so certain practical aspects about designing these AI algorithms that I've come across during my journey is what I would like to explain, would like to share with you all. I will try to not go too much into the technical implementation, rather the challenges that we face and how to mitigate them. So this will be the outline of my talk today. What and why of extended reality, some applications of XR across major industries, some of the industries that we touched, designing AI algorithms for XR, the requirements and the challenges, and then the revolutionizing XR with generative AI, which is the talk of the town today, right? Generative AI, how it can be integrated and used with XR industry, and lastly, we will have some food for thought at the end of it. So quickly, just the basics, because we all were already, even in the last session, we were talking about various aspects of VR. It was an amazing session. I thoroughly enjoyed, sir. But quickly, for anyone who doesn't know, and I want to just clarify the definitions that I'll be using. So, virtual reality, what is it? When you are disconnected with your real world and are totally immersed into some other reality, that is virtual reality. So your vision is essentially blocked. Your senses are all working, but your vision is blocked and you do not know where you are. That is completely virtual reality. That is great for any kind of immersive training, learning, for simulations. So for all of that, virtual reality is great. The second one is augmented reality. In this one, you can actually see your real world, and certain virtual overlays are created on top of those real world scenarios, right? So you can have certain navigation, some information, and then lastly, the most difficult and the most advanced reality is the mixed reality, in which you see the real world, you also see the virtual world, but both have some kind of physical interaction with each other. For example, in this example that I'm showing, the balls are all virtual, the character is virtual, but those are actually interacting with the real floor of your home. So you throw a virtual ball, it will actually bounce back from your real world. So there is some physics involved, and this is called mixed reality, right? So whenever there are certain physical interactions between virtual world and the real world, that is what is called mixed reality, right? So all together, all AR, VR, and MR together are termed as XR or extended reality. So certain headsets which can integrate all three aspects, those are termed as XR devices. While most of the market is today is taken up by VR devices, but the market is now slowly heading towards XR devices because there is a huge lot of potential in mixed reality and augmented reality as well. Why should we bother about XR? It can be because when the first introduction to most of us, when we come across these terms as XR and VR, we think that it is mostly for simulations and for gaming purposes. But if that were the case, then this particular study done, this shows that the market cap would reach up to 345 or 346 USD billion by 2030. No wonder Dubai and UAE are already ahead, quite ahead. They now have a ministry for XR. There are certain universities already working with a lot of student intake, which is completely virtual in nature. So they are giving out courses completely virtually, right? So XR is something where the awareness in students like us, it has to be there because XR is reaching applications and potential beyond gaming, beyond simulation. So certain use cases that I felt were necessary to discuss here. The first one is digital twinning. Now, digital twins is not a new concept. Again, I will go back to the definition just to make the definition clear because our perception of digital twin from the small videos of some talks that we have taken up might be a bit distorted. Generally speaking, digital twins come across as replicas of certain environments, replicas of certain processes, replicas of industries, factories, some setup, some classroom, right? But digital twin in its most essential sense is not a replica, not just a replica. A replica can be termed as simulation, right? Virtual simulation. However, digital twin is a real-time replica. Whatever is happening in certain factory, which is few kilometers or few cities or few countries away from me, I can in real time understand what is happening with all the IoTs, with all the sensor information that I am getting. I can know which machine is working, which is overheating, which is creating certain vibrations. Some kind of predictive maintenance can also be done. Why? Because I already know something is overworking, something is heating up, right? And this needs to be fixed ahead of time so that my assembly line does not stop, right? So this is called digital twin. Now digital twin has been around for the past 15 years, and but its real marriage and real visualizations come with XR, right? Humans understand processes and functionalities a lot more with their spatial understanding, right? Rather than textual information. For example, I'll just give you an example. I am a manager and I walk around a factory floor assessing different robotic arms which are assembling certain vehicles, right? Now, all this information suppose is coming to me via digital twin in the form of a 2D desktop textual information. I get information, sensor IDs, such and such is giving such thermal reading, such pressure reading, the motor reading is such, voltage is such, right? The understanding is very difficult. It is not intuitive. We are not used to reading so much text and understanding ID number. This robot is not malfunctioning. I cannot actually make out which robot. I have to be an expert in that, right? However, think of it in XR sense. This, what you are seeing is a virtual replica. So if I'm just visualizing it in my 3D in the immersive environment, and I get a virtual overlay on top of that robot with a red capsule, that the head capsule shows that something is going wrong with this robot. Spatially, I can understand which process it will affect, which assembly line it will affect, where I have to take some preemptive measures, right? So spatial and intuitive understanding that you get with XR visualizations, with digital twin prowess, right? That is amazing. That is why it is almost like a marriage made in heaven, right? So this is one of the applications that is doing wonders. Mercedes has taken up, already done certain case studies with NVIDIA doing exactly what I said. Multiple automotive industries have taken up digital twinning with XR in their case studies, and they have shown how much billions and billions of dollars of saving they have done in the overall processes, right from the designing to discussion to actual manufacturing to actually distribution of the processes. So they have saved so many billions because they do everything in the digital twin or in a virtual space, right? So this particular is case studies from Ajna Lens, where we are doing some kind of remote assistance and remote field visits. So we know that experts cannot reach everywhere, and without an expert, certain processes and certain maintenance work can take long hours, and we in manufacturing industry decreasing the entire maintenance time is a huge aspect, right? So here what we are showcasing is that with the glasses in place, it is a form of first person video calling, but in 3D. It's not exactly video calling because in 3D whatever annotations the expert is doing, that unscrew this particular screw, that annotations the user is getting on the actual object, anchored on the actual object spatially, and he knows exactly which screw to unscrew, right? In video, you might not have the depth information if there are certain wires or certain buttons, right? Which particular button to do, what wire to separate, what to do, right? So here you get the exact spatial anchors and the spatial annotations by the expert, and the user here or even a robot here can actually do with the expert's guidance. It's almost like remote surgery, right? So this is an amazing use case. Of course, we know But what I try to showcase here is in mixed reality space. So in VR, of course, the visualization is amazing. All the CT MRIs were always a 3D data, right? But we always use 2D desktop to view these CT MRI images. Uh, with XR headsets, with such wearable computers, you can see the models the way they are actually. But here, what we are showcasing is that the actual scans and the 3D models of the actual patient are being overlaid on top of the patient in the pre-surgical phase, and the doctors are able to plan out the depth of the incisions to be made, the location, and minimizing the accidents, minimizing any errors there, right? So this is an amazing use case, but of course this comes with amazing AI algorithms behind it, right? Anchoring of the models at the actual position without any shift, and while the human's head is moving, the doctor's head is moving, how to keep it anchored there. That takes a lot of AI and CV algorithms behind the scenes. Right. I wanted to showcase one of the clips from this series. It is there on Netflix. I was watching this a few weeks back from The Good Doctor, and they are using Microsoft HoloLens, an amazing device. Microsoft has been a pioneer in this field. Hats off to them for designing a lot of things for us, opening a lot of arenas there. What they are doing essentially is they are doing virtual surgeries multiple times, and this is an actual digital twin of the patient's heart with certain malformations, right? And they are doing the surgery, they are failing, the virtual replica actually dies. They showcase that with the ECG, that with the incision that they calculate, the patient actually dies virtually. And they do it again, and they do it again, and they do it again. This is something that the doctors cannot do on a real patient. This is also something that you cannot do with simulations only, right? Because every heart is different, every malformation is different. So having a real model and then also behaving the way a real heart would perform or a malformed heart would perform with all the different parameters is something that is amazing. And this is where the field is. It is not something of the future, not something that cannot be done today. It is being done in different degrees. Yes, a lot has to be done further, but this is where the application potential lies, right? So they are doing the surgery and again they see the so in this clip they show they did it actually 4 times, and finally they came up with the right depth what they have to do. And again, this is XR for education and training, hands-on immersive, low risk, and highest knowledge retention. So multiple studies have been done, right? Theory is lesser than practical, lesser than videos. Videos is lesser than practical, and we all say Indian, education needs lot more practical knowledge. But then think of, we are in a premium institute, but think of very remote ITIs, training institutes in remote rural areas where there is not enough, this is, they teach skills like welding and painting, right? Uh, in most of the ITIs, they would run out of fuel and, whatever spray paint, they would run out of experts, teachers, right? They would have students graduating even without ever doing any practical, and this is a practical diploma that they have to do, right? So Indian unemployment is not because not enough jobs or not enough graduates. It's because graduates are not skilled enough, right? And the practical can be done because here the spray painting demo that I showed here, no actual spray is happening, right? It is all virtual, but you develop the right muscle memory because you are playing with the right controller, the right gun. It is not a game controller that you are doing with. It is the actual spray painting gun. So you actually learn with the right physical memory. So it is very important for hands-on trainings that you learn in your actual scenarios, in your actual environment, with the right risks also. And there, the wind simulation that we talked about in the last previous session, right? I was thinking there is a certain courses are there where you have to learn welding on very difficult scenarios, like inside a turbine or on a windmill or inside a furnace, right? And those experts get paid a lot, but because they are trained in certain scenarios, these all can be done virtually. But the immersion and the reality is very important. And there, such haptics, such wind simulations, heat simulations, cold scenario simulations can be of immense help, because the person would actually feel in those scenarios what can he expect, right? So these are the certain applications that virtual reality can actually have been very instrumental in. And this is very close to my heart. I work with a lot of defense projects. I'm currently working with 3 active defense projects with XR. And I cannot talk about all the projects, but one of the projects that we work with is the right one. Uh, this one. If you see here, this camera that you see, this is a 360-degree night and day camera. And what happens is the person wearing the glasses is actually one of the 3 persons who actually, handles the different guns of this tank, right? Now the problem with tanks is because it is supposed to be very rugged in nature, there are no peepholes or windows or anywhere to actually see your surroundings, immediate surroundings. So your situational awareness is very low in this aspect. So what we do is, with this camera in place, what we do is we give the outside 360-degree environment and reconstruction inside the tank, and you can play with the transparency between AR to VR. Basically, you can see the inside of the tank as well, and you can play with the controls and you can see the outside, almost like see-through. And the project's name is also see-through armor. So you see through the armor of the tank, right? So there are different defense projects which are benefiting from these XR technologies. So it's a very interesting thing. And this is the best of my knowledge where current XR industrial applications, lie with. So the biggest sector is with the education. Education covers all kinds of training, whether it is industrial training, whether it is any kind of training, skilling that is covered in education. Second is the healthcare and medicine. Third is retail, because you would want to virtually try on things, you would want to virtually shop, and then the metaverse talks, which have died down in the recent past. But it came up a lot 2 years back, where people were buying NFTs and land in metaverse and making shopping malls in metaverse. So yeah, all sorts of things. But yeah, still, even without all of this, uh, very shiny things, still in retail industry there is a huge market for XR technology. And then there is the architectural visualization, interior design, exterior design, planning before even constructing on the right land, terrain, how the different environmental factors, vastu, feng shui, everything can be visualized before you actually do anything, right? And of course, then the manufacturing, automotive. These in percentage, it's a bit less, but the impact we see in these 2 industries is huge. So a lot less in number in terms of case studies, but the impact per case study is very, very big. So that is the kind of applications that you can expect with XR, and why I have discussed this before I jump into the AI algorithmic part is just to get more of your interest where you can foresee XR other than gaming as well. So designing AI algorithms for XR. I'll be discussing certain core algorithms that are necessary for any XR experience that have to run as services in the headsets. These are like SLAM, simultaneous localization and mapping, spatial reconstruction, spatial understanding, hand tracking, eye tracking, different kinds of interactions, 3D object pose detection, or in fact it is 3D, or you can term it as 6-dot object pose estimation, uh, and NLPs, dialogue systems, conversational AI, and personalization of experiences, and different navigational and interaction algorithms. I'll be covering a few. So, talking about SLAM, simultaneous localization and mapping. It's a very old, algorithm, very CD. Not necessarily AI is not necessarily needed here. Uh, the idea here is, why do we need SLAM in the headset? Because we have to track the head, HMD, head position, right? When we see a virtual object, suppose this bottle lying here is a virtual bottle lying on this table, and I move with the headset in place, the bottle should look like it is static there on the table. How do we actually make this happen? It is because I first calculate in this environment where am I, right? And to understand where am I should know what is this environment. And these are the two questions that SLAM answers, right? What is the environment that is around you, and where are you in that environment? Very simple. So I get the 6-dot position of my head at all times. And when I know the 6-dot position of my head, I can articulate and calculate the new views on every frame, on every motion. And because as I move towards the left, the view will be different. As I move towards the right, the rendered view will be different. This is all calculated by this head tracking. Correct? So SLAM is very simple. The user wearing the headset, he tracks his head is tracked. Then the rendering happens. Rendering is the composition of the virtual over the real, or the any kind of new view that you are calculating. That is called rendering. The rendered frame is then displayed on the headset, and then the headset is experienced by the user. The new frame is experienced, and then he does certain kind of interaction, whether he moves, whether he interacts, whether he does anything, right? So this is basically SLAM. The challenge is all of this has to be done in 10 milliseconds. I'll come to that why 10 milliseconds in the later part, where I will be discussing the challenges. Second is spatial mapping. Again, we have already covered that in SLAM. We do map out with the features what is the environment around me. But we also need certain kind of reconstruction. We don't just need the features, we need actual meshes. Why? Because in the first example I said, what if I have a virtual ball in my hand and I throw it and it should bounce from the real floor or from the real table? For this to happen, I need the mesh reconstruction of the floor, of the table, of the furniture, of the walls, of all the static things around me, right? Once I do this spatial reconstruction, that is when I will know where to apply different physics, right? Physics is not just bouncing the wall. Physics is, if I have to place certain things, without the understanding of this physics, it will look like I have placed a flower pot in the middle of the air, which is not very realistic, right? We will need certain gravity to work. If I just let go of the flower pot, the virtual flower pot, it should actually go down and it should crash and it should be destroyed on the floor. All of this needs, this realism will come only if I know that there is a floor there, right? So all of this you see in this gift actually done with the mesh reconstruction, right? So planes are detected, horizontal planes, vertical planes, and then on top of that, once we have the mesh in place, we do also certain kind of segmentations. Why? Because in the later part I will be discussing, we do have to also understand spatial mapping and reconstruction paves the way for spatial understanding, which is very important for the new age or the next stage XR applications. So how is spatial reconstruction done? Very simple. It is via photogrammetry. You might have heard about this. This is structure from motion, one of the methods. A moving camera, if it is, taking images of a single 3D model, will be able, if it covers all the views, then it can triangulate. Via triangulation, you can actually create the 3D construction of the 3D model, right? So this aspect of spatial reconstruction can be thought of as model or some kind of 3D model generation in virtual world, right? So XR, what is one thing when you think that if I had to make a virtual game, what is the first challenge that you would be thinking of? I know me being an engineer, I'm not great with art or 3D modeling or texturing, right? And that's the longest work hours of any 3D game making goes into that, right? So we generally end up buying certain models or freely downloading certain models from the internet. But what if, in my experience, I want this particular sofa in my room, right? So what I will do is I will use this photogrammetry. I will take a video from all views, from all angles, and feed it to the algorithm, and I will get a segmented, exactly textured, physically, dimensionally valid reconstruction of this sofa. So this photogrammetry is used for very high textured, very high detailed modeling technique, okay, for certain objects. But what if I have to construct the spatial reconstruction of the entire scene, not just of the table, but of this entire room? So nerves, the neural rendering field, radiance field, these these algorithms were very popular 2 years back. NVIDIA was doing amazing work in this particular. I've actually noted down a few papers. If you would like to take my presentation, some papers that I've actually used are helpful. So I noted all the sources here. Um, so why this was a game-changing algorithm was because in photogrammetry, if you miss taking certain view, because it is a CV technique, it could not calculate those views where the images were not taken, right? In this particular neural variance field algorithm, the models are trained such that with very few 2D images, it can reconstruct certain novel views, right? So the result of this optimization is the ability to produce novel views of a very complex scene, not just of an object, but of a complex scene. So with very few images, you can actually completely render 3D views of the entire scene also. Okay. But as I said, this neural nerves were very popular 2 years back. Why? Because Gaussian splatting came into the picture. Gaussian splatting, again, very similar. The outputs are very similar to nerves, but they use, we all know, I hope we all know the point clouds, right? When you use 2D with the depth, you can get the point clouds. What if the point clouds were not made up of points, but of a Gaussian distributed probability zones, like a splat? That is how the name comes. And these splats are actually optimized so that it takes the shape of the 3D model, right? So you see on the second row here how the Gaussian splats when the optimization happens, these 2D Gaussian splats keep expanding and contracting on the surface, and thereby we end up making the complete 3D model. This is a very optimized model, and it is currently viral in at least my industry. And the amazing thing is that there is nothing neural about it, but everything viral about it. Sometimes classic CV can also win, right? So we know that we end up. That is a problem with a lot of freshers that come in the industry. That AI is making rounds, generative AI is making rounds. So, but we cannot let go of the classic CV in certain cases wherever we want certain performance, wherever we want certain latency reductions, we end up actually using a lot of CV. So knowing your basics in CV is crucial before we end up using AI. And here I have compared when to use what. All three are very important. I personally would be using photogrammetry for highly detailed objects or assets in my experience, which I term as objects of interest. So suppose I have an experience of training with certain machine where I will be interacting with different parts of the machine. That machine I will be making with photogrammetry because that will be the most highly detailed texture. But because it takes a lot of compute, very high processing, a long time, and a lot of input from me because I have to take videos and images from all views, from all depths, and all of that, right? But because that is the object of interest, I will put in that much work into that. Nerves, I would actually not end up using at all in my industry. Why? Because you need very high end servers. Like even A40, A70, nothing works at the end of the day. These take like servers and servers for training, and you end up doing POCs with trained models. So not very commercially usable right now. Maybe with more optimizations it will be great. But Gaussian spanning is great. It is fast. It is real time. But it ends up giving us lower details and fuzzy edges. I'll be showcasing an example of an in-house Gaussian splatting. But in most of the cases, when I want to create an environment, the details are not as important as is the object of interest. We have to populate the metaverse a lot of times with a lot of assets. So all the details need not be there in far away walls and forests and all of that, right? So for that, I use a lot of Gaussian splats. So this is one of the examples from Luma Labs. Again, they are doing wonderful work in right. And one more thing, this is kind of video calling feature via XR, but this is a memory frozen, like a frozen memory that they were actually some couple of guys, maybe they got a startup idea and it was frozen in memory, but it's a 3D spatial reconstruction of the entire scene with very few images. This was done by NVIDIA, right? So this is and you can actually see walk around. And there was an Iron Man movie which actually had this kind of scene where he actually went back and showed some kind of memory with his father. I think a lot of inspiration from such Marvel movies. A lot of our patent ideas also have come from Marvel movies, so it's never too bad to have a look at them just to get some inspiration, right? Uh, so this is from Ashna Priti, that is in-house, video to 3D model that we train. Just feed in the video. It's a drone shot of a temple, and this is the kind of output that you can generate. You can see. Just I will. If you see, there is what you see and which passes away as a beautiful cloud-like things, right? Those are actually flaws of this algorithm. As I said, that it misses out details and it creates certain noise and edges and at the end of the environments, right? So it passes away like clouds here. So, but it is actually flaw of this particular. But if suppose you have to experience this in a first person setup, right? You are outside the temple, taking a walk around the temple, then all of this would not matter. So Gaussian splat is an amazing technique that we can utilize for populating the backgrounds of a lot of experiences. So once again, spatial reconstruction born out of laziness of certain people who are not great at art, and they do not want to put hours and hours of manual working, modeling, texturing, making a lot of things in Blender and in different Unity and Unreal kind of game engines. Now coming to the spatial understanding. So what we have done till far, we have tracked our heads, we have done spatial mapping, we have done spatial reconstruction, and now we are doing spatial understanding, right? Spatial understanding needs all these inputs before it can do anything, right? Now is where AI comes into play, and whatever you might have read so far, where from text you can recognize chairs, so many algorithms are there, JODOs and detections and recognition algorithms. But think all of that in 3D, right? Because now you will be segmenting the meshes. You will be localizing and recognizing from the 3D shapes what those things are. And why it is important is because we already have reconstruction things in place. So if I want to almost like a 3D inpaint this particular chair and replace it with a different asset, I can do so, right? So this is the kind of spatial understanding that we want. This can be achieved by algorithms like segment anything and 3D diffuse, or segment anything and NURBS. Segment anything is a very popular algorithm from Meta. Uh, Generally, people feel it is for 2D, but its variants are now coming in 3D. Versions that can be segmented now with segment anything model. The name itself says segment anything. With certain prompts or even without prompts, it can segment different things. Common things can be segmented even without prompts, or you can give textual or click kind of prompts to segment the things of interest. It is an amazing algorithm. You all can try that. It's Meta has outsourced it. Open source. Sorry. And why NURF and 3D fuse with it? Because once you segment, then what? You will replace it with something, or you will use it for something else, right? So you would again need to beautify it, make it into an asset. So here I segmented out this hot dog plate, but I still had to use nerves to reconstruct it beautifully and create a fully textured model to be utilized elsewhere. Right? It is almost like a person saying, I need this asset in my virtual world, and it can be directly picked up and placed there. Right? And now coming to this is an algorithm very close to my heart because I've been working on it for 6 years and it is still an open challenge. This is fixed drop object pose estimation. I'll be discussing the why first. Why do we need fixed drop object pose estimation in XR? Certain use case that I have shown here is, suppose this is certain, I might be wrong, but it seems to be some engine or some machinery part, right? What we are showcasing here is on the go there is some kind of training that is happening. How to remove the outer part of this engine, I can visualize right there, anchored on the engine itself. So this is not virtual, this is my real surrounding. I go to my car, I open my bonnet and I know nothing about it. This is where 3D or 3D object detection or 6-drop object pose estimation is very important. Why? Because you do not want the virtual thing to be working elsewhere, and then I see and I feel, oh, there is a gross difference. I do not know what to do now, right? The things are anchored. The information is anchored to the actual object. Now, in the video, you cannot get the complexity of it, but think with the headset, you are viewing it, and you as a human are moving your head, you are moving around the engine, but the information is logged to the object. That is very important for many different enterprise applications, right? So here I have discussed that CAD-based 3D object pose detection using sparse region-based models, using shape, texture, and slam-based cubes can all be used. So this is how we are designing the particular algorithm. Reconstruction and detection simultaneously can also be done with CAD-less techniques. Suppose I do not have the CAD object model of this, then also it can be done with these techniques, OneForce++ and NVIDIA's bundle SDL. But it takes again a lot of time because it first reconstructs and then it tracks. So reconstruction itself needs very high-end servers and good amount of time. So maybe in 2 days, 3 days, you will get the model and then you can. So we end up using the CAD-based object tracking because in most of the enterprise problems, they usually do have the CADs of different machines. Here, this is actually a demo made by me only, I think. Because we work with a lot of IDIs, I have shown how this particular object pose estimation can help us. This is a welding plate and this is the actual welding gun. Okay. The overlays that you see now on both the welding gun and welding plate shows the accuracy of the object pose estimation while I am wearing the headset. The jitter that you see is my own head. And so the video does not feel stabilized, but in the headset you will not feel recorded, you feel the head movements. And what is the importance of that? Suppose I had to do the virtual training now, and I do not know what is the actual term for it. When you press the welding gun and you see the jets of the welding gun, But if I know exactly the position of the nozzle and the groove of this welding plate, then I can animate only that, right? I will not showcase the virtual overlays here. I will animate the spray happening and the welding happening, the beads that you see of the welding metal, right? All of those can be virtual now, without any tracker or controller on top of my gun. It is all visual. With my own cameras, the cameras on my headset, I can do all of this object tracking, right? And here why I have shown two is because this is a multi-object tracking without any depth. So it's very optimized. It runs at 50 to 55 FPS on the headset. And that is when we come to implementation of AI algorithms and the challenges associated with it, right? So all of that I have discussed till now. There are, for implementing AI algorithms, there are majorly two approaches. Very simple. Either you port the entire AI models on the headset itself, where it runs locally, or you send the data from the headset to high-end servers, all kinds of data like frame data, MU data, we have n number of sensors on the headset. You send all of data to the high-end servers. The AI models run on those GPUs, those servers, and you end up getting the either just the crunch information, the data, and you render it here, or you get the rendered frames itself from the high-end servers. These are the two major techniques. The third one is hybrid, where you do some operation on the headset, some operation on the high-end servers. The method one, which is the porting of AI models on XR device, the pros is you end up getting a low latency, right? Because everything is happening here, latency is very low. There is no network dependency, you can work offline. And of course, privacy, which is a big concern. Why? Because I have so many sensors, I can capture everything around you. Everything means all the spatial information around you, and then sharing it outside the headset to some high-end server, might be a concern for a lot of enterprise, for a lot of B2C customers as well. Uh, but the challenges, those were the advantages. The challenges is the hardware limitations. Most of the XR headsets, the compute resources are very constrained, right? These are almost like high-end mobile phones. So what amount of AI can you really port into that mobile phone of yours or on the headset has to be thought of. It needs very high-end, skills in optimizing and really working on C and C++, and you have to do away with Python. So all the AI, magic that you can do with Python, that will not work when you're porting algorithms directly on the headset. There's some kind of echo.
It's okay.
Yeah. So, and then the model optimization. We call it quantization, right? Large AI models need to be significantly compressed and optimized, often at the expense of accuracy and performance. Correctly, many of us must have done this. If you do any kind of mobile AI and quantize the AI model, it loses a lot of accuracy and performance as well. And then the thermal issues. How much compute can you actually put on the headset? Why? Because certain core algorithms are always running on the headset, right? Head tracking, SLAM, always running. If I also put spatial reconstruction, mapping, and understanding, then those things are already running on the headset. So the quota for any other AI model is always very low. So those are the challenges that we end up facing when we have to port AI models on the headset itself. The techniques to mitigate certain things are, again, going back to model compression techniques, right? Or on-device AI accelerators like Apple Vision Pro, the latest headset from Apple. They incorporate not one but two processing units. They have a separate processing unit just for certain AI applications. So their core algorithms are running on a different chip, and certain other AI applications they have. So they have a lot of quota for doing that. Um, and then the efficient algorithms. Designing of very lightweight AI from the scratch, not porting already trained models, but designing from the scratch is something. So we already know there are architectures from TF Lite and different, platforms do exist where you can, from the very scratch, you have to think on all the levels. how to optimize the entire algorithm, not just AI, but entire algorithm. If you are thinking that you will end up porting the entire algorithm on the headset. Method 2 is about streaming data for AI processing on servers. Of course, you end up getting unlimited computational power, right? Whatever server you can rent it out, and there is no limit to it. Energy efficiency for the device, your device will not heat up because it is essentially not doing any computation, it is only displaying the information. And for scalability, so if you want to scale to a number of users, have multiplayers doing certain things, all of this can be done easily with servers. The biggest problem is latency. Why? Because unlike different AI applications, we know of certain AI applications like surveillance from CCTV cameras, right? They do say that they are real time. Their real time is very different from our real time, right? Number plate recognition of passerby. It is okay to get 1 second latency, 2 second latency, right? They have 2,000, 3,000 cameras in a single area. So they have to crunch and do everything. So 1 second, 2 second is an acceptable latency for them. As I said in the beginning, for us, it is less than 10 milliseconds, right? Why? Because I want whatever AI has to be, suppose I do a human face recognition on the go. I'm a surveillance inspector going on the airport, and like Mission Impossible 3, I want to recognize certain people. And I want that recognition happening in 3D on the actual face, right? What if I move out and that box shifts from the face of that person? Right? There is no spatial information there. Once the box of certain name might be stuck on the face of some other person while I'm moving, right? Or if I just move my head, I'm not even moving, I'm just moving my head. All the information that I see in these frames can be moved and shifted. So the latency is a huge concern in XR. So most of the latency that we think is acceptable in most other AI applications is not acceptable in XR. Bandwidth and network stability, right? When I said this particular headset has 6 cameras, if we have a certain, different variation where we have eye tracking cameras also, then we have 6 plus 5, 11 cameras. If I have depth camera also, then I have 11 plus 1, 12 cameras. And then you have IMUs, you have microphones, you have n number of other sensors as well. All of this data, if it has to be crunched for certain kind of AI application, and if it has to be sent over this network to these servers, in itself needs a lot of bandwidth, right? And whatever we talk about, we need, and I think XR will be the biggest customer for 5G and 6G applications. And that is why, Airtel and Vodafones are doing a lot of case studies with XR, because who will end up using 5G? The entire bandwidth. We are happy enough with any kind of video streaming over 4G networks, right? Our YouTubes do not buffer anymore over 4G if you get proper 4G. But where is our real need of 5G, where we end up using it entirely? One of the use cases is XR because of the bandwidth requirement. So unless we end up getting network stability everywhere, right, we cannot actually scale and provide AI-based solutions for B2C market. That is a challenge. And of course, the privacy concerns that I already discussed, right? So streaming the data for AI processing, the solutions could be edge computing, right? Edge computing is where the remote servers are not very remote; they are somewhere near around you. So we will end up latching onto a server near you, right? All the Mumbai people will be latching onto a server based out of Mumbai. All the Jabalpur people will be latching onto a server which is in Jabalpur. So once the distance is actually, lower, the round trip latency actually reduces. Second is hybrid approach, where we implement and we almost trick the user into feeling that no, this AI solution is running real time. We do some kind of warping and prediction and do something here on the headset, but the actual AI is being processed elsewhere in the server. So the output that we generate, which is coming with certain latency, we do certain future prediction and showcase something real time here. Okay. So those are some certain hybrid approaches. Again, it's a huge field that has to be explored a lot, right? But it can be one way. Optimize data streaming, of course, right encoders, right hardware encoders, right data compression techniques, and everything that we can do to reduce the bandwidth requirement has to be implemented. Best practices, as I say, I always end up telling you what I end up using for certain applications. As I told you in the spatial reconstruction, what I would use, the different techniques for what application, same way. For porting AI models, I would use these in applications which require very low latency, where the privacy sensitivity is high, and where we want real-time processing, right? So here, SLAM, real-time object pose estimation, gestures, all of that has to happen on the headset. It cannot happen, like it will not happen elsewhere, unless we we get into a very different innovation of bandwidth and networking. And for streaming, I would use it for high complexity AI tasks that require powerful computing, like remote medical diagnosis. Now, diagnosis is not something where few seconds of latency is okay. You are not doing the diagnosing and directly performing the surgery, right? You are just planning out your surgery, so that is fine. Photorealistic rendering of complex environments in VR, right? Uh, while I'm moving in this environment, in the backend, this reconstruction is happening. It is okay because after some time, it can be fully reconstructed and I can reutilize it with the location specific mapping. I will reposition itself. So this reconstruction can be saved and can be recalled every time. So even if it takes few seconds, few minutes, even few hours, it is fine if there is a need of this reconstruction again and again. So I can do it once, almost like offline online structure. You do the reconstruction once offline and use it online whenever you require. And of course spatial understanding, and so again spatial understanding and all can be almost cached in the memory unless you change your setup. So all of that can be, so the planes, the walls, all of this mesh can be constructed and kept in the memory cached whenever you are in the same setup, right? We do it very intelligently. So if you have suppose 4 offices or 4 lecture halls, you have reconstructed everything. So whenever you come, you switch on the device with the key feature points, it can actually recall which structure to pull and how to place it. So you don't have to put it again. So those algorithms already exist. I'll be touching the biggest challenge that we face, which is latency. More specific in our case, motion to photon latency. In XR, it is called motion to photon latency. What is motion to photon latency? Very simple. Headset, you do certain motion. You either rotate your head or you move. This motion is captured by the cameras and the IMU. This sensor data is provided to the trackers, the head tracking unit, the SLAM. The pose is generated. This pose is fed to the application, which is a renderer, which will use this pose to make a new view of your virtual environment or your augmented reality, right? The frames are generated. These frames are provided. These frame buffers are provided to the display, and the display finally showcases it to the user and the photons, right? So, and you see, you start with the motion, you end up with the photons. So, everything in between is motion to photon. So, whatever we do, whether it is the first approach, which is porting of the algorithms on the headset, or second, which is using a high-end server for doing the bulk of your processing. In either case, motion to photon latency can never be made zero. Why? Even if we use cameras, high-end cameras, which are I have taken some ideal cases, 60 fps. There are 90 fps, 120 fps as well, but for the sake of practicality, 60 fps. Trackers, most of the SLAM algorithms, which we know run roughly at 30 fps, but we do optimize it for the headset. So headset SLAMs now work at 60 fps, 90 fps also. I've kept it at 60. Renderer application depends on the experience maker who makes the games or the experiences or the virtual experiences. So they can roughly be between 30 to 90 hertz. If the person is very high skilled coder, can make a 90 hertz game, a 90 fps game. If not, it may end up being a 30 or even lesser. It is a 3D game, so it end up using a lot of processing. And this is, I'm talking about on the headset game. And finally, the display. Most of the displays are lesser than 90 FPS. Our headset is 90 FPS, so I'm taking that. With all the hertz, I have taken the milliseconds for each exercise, and there are other, nitty gritties and um, data transmission latencies also in place. I have not taken them into account. I have just added these latencies. So the best case scenario, the motion to photon latency is 54 milliseconds. Worst case is 77 milliseconds. What we want, less than 16 milliseconds. Why? Because anything above 16 milliseconds, when it is playing very close to your eyes, you can actually see the difference in the motion and the final outputs. If I do object tracking and I have the mask in place, the mask will actually shift even if the computation and the pose calculation is accurate. The mask will appear to be shifting or almost like floating. It is like a swimming artifact that is it. I wanted to put in a video of that, but grossly I could never, record from the headset or something. But if you do not optimize these things, your virtual objects will never feel stationary. They will always feel like with the head they move a bit after the motion. So if you move left, the object will come behind, almost like a swimming or floating effect. This ends up creating the immersion is, you end up getting lesser immersion. Why? Because everything feels in the real world static, but your virtual object will, even if it is made with the best texture, see-through and any real, but because it is not static in your real world, you will not feel this is realistic, right? And comfort, because of this latency you end up getting motion sickness, dizziness and disorientation. So whatever these are the flaws with a lot of VR. People say I get dizziness, I get, it is either because of the weight that you are putting on top of your head, or the latency that all the headsets suffer from. Some have less, some have more, but all the headsets suffer from this latency. Techniques to mitigate motion to photon latency: optimize hardware and sensors. Low hanging fruit. Do it first. Why? Because any algorithm or software optimization cannot take away from the latency that the sensors itself induce, right? If the latency in capturing an image itself is a few milliseconds, then you cannot do anything about it. So cameras and displays, IMUs are very fast. Like most of them are 1000 hertz. So IMUs are very great in doing other, approaches that I'll be talking about. But cameras and displays can be taken of higher FPS. So in our headset, we have the best display in the market right now, which is 90 hertz 5K, and that is one of the reasons why the latency is lesser compared to other headsets. Network and streaming optimizations. Of course, I have already talked about that. If you are using any kind of remote computing, then network and streaming optimization has to be done to the best of the available algorithms, or make your own proprietary algorithms. We have actually we had to end up making our own proprietary encoders and formats for streaming because we had to do a lot of AI operations. Late latching. Why? With late latching means you use the pose at the very end. Suppose you have a game, you do a lot of mathematical calculations, right? A lot of, and at the end, you can apply the pose before or end. The choice is always to use the pose at the very last while you are computing a frame. So once you do that, you end up using a very fresh pose in your experience. Now, this is assuming your game experience is running at a lower FPS than the pose. Okay, your slam pose is the tracker that is generating the pose. Suppose that is generating the pose at 60 or 90 FPS, and your game is running at 30 FPS. You should not first use the pose and then do all the calculations, all the simulations and whatever beautiful wind simulations and fighting animations. You should do it for every frame computation. Do it at the very last, right before you display, right? This is called late latching. Then there is asynchronous time warp, ATW, very important. Essentially what we do is you get the pose, You do the rendering. While you are rendering, you are already a few poses late. So by the time you are viewing it, you are already late. So what you do is you project the pose sometime in the future using the historical data, predict the pose sometime in the future, and you create the frame for that future pose rather than of the current pose. So you know you already will be at the future pose while you will be displaying it, right? So in essence, that is what we use. Single buffer rendering, there are multi-buffer rendering. The best way is to use a single buffer rendering. It streamlines the rendering pipeline and directly, uses the display buffer, eliminating any intermediate steps. So this is a bit technical. If you go into game implementation, that will be useful in all the game engines. This is a setting that you can apply. The synchronous reprojection, it re-renders the frames quickly in response to slight movements between frames to maintain immersion, almost like an interpolation between the frames, right? And asynchronous phase award is also very similar but a bit different. It generates synthetic frames by using previous motion data to fill in the gaps when the system can't maintain the desired frame rate. So if your game, whatever you do, has so many assets, very high end, very photorealistic, cannot run above 30 fps. You have made, and it will, whatever you do, it will not. You will end up, you will have to, do away with certain voxels and a lot of data. Only then it can, increase the fps. What you will do, you will use asynchronous spacewalk. It will end up making your 30 fps game into 60. It will interpolate the frames, making pseudo fps. Yeah, so that was the biggest challenge that we face in the XR industry, and I discussed certain approaches that we can work with for mitigating this motion to photon latency. Even if you are not from the industry, not from XR industry, even for AI, a lot of this inspiration can be taken to mitigate similar challenges in other fields also. So a lot of innovation happens when we take inspiration from different fields. So this is also, you have to take inspiration from different fields because the problems might be similar in different fields. I'll be discussing the role of generative AI in the evolution of XR. So many of you must have heard about these algorithms, right? ChatGPT is text to text generative AI. You put in a text prompt, you get the text and information output. DALI, Mid Journey, StyleGAN, Stable Diffusion, all are very popular techniques for text to image generation. So almost like content writing, image making, all of this, the jobs are now taken over by AI. So just put in, I want such and such image, and all of this can make beautiful image. A lot of images that I have used in this presentation are also generated by these Gen AI. But what about 3D assets? I'm talking about XR. Why? Because making an image, making video creatively is a difficult task, but making a 3D model with animations, textured is even more difficult, right? Uh, I know how many hours of operation it takes to make a simple but very photorealistic model. And these artists, they charge a bomb. They take months to create such models, and that is why XR creation journey is very long. If I have to make certain training, nothing less than 3 to 6 months, whatever, even if it is a 2 minute training in the XR headset. If you make photorealistic, these are the kinds of timelines we work with. So why generative AI is important? Because as we have expedited such creative processing and uploaded it to generative AI, can we do the same for 3D asset building as well? So I've skipped through certain very important but very popular text to 3D model generation, and directly I've come to text to animated characters, not just 3D character but animated characters. So this is the prompt I gave, and I've noted the name of the algorithm, avatar clip. A skinny ninja that is raising both arms, and this is what it generated. Right? A tall and fat Iron Man that is running. Why I have given such prompts is because if I give any normal Iron Man running, you can get a lot of such assets. But if you want something very whimsical, then yeah, right? And all of this is possible with a text prompt. Truly generative AI for 3D aspect. This is Masterpiece Studio, which is a complete 3D character deployment. So you put in like, what does your character look like? Blonde Viking with a beard. That is what was inserted, and that is what it created. A blonde Viking with a beard. How does your character move? Walk and twirl. Right? It walks and it whirls. So you define the physical characteristics and also the movement. You can also do, because humans do like to do certain touch-ups. We never like generative AI enough. So you can end up doing some more touch-ups and create more realistic textures if you want. Do certain tweaking, and you can put it in the environment of your liking, which is again a generative environment. So no months of art making and no weeks of animations. Everything is done in very realistically and with text prompts. Maybe it will happen with speech prompts also. That's not a very difficult thing. So I can just speak out what I want, and it should be able to create 3D experiences. And this is another approach where if you know animation a little bit, you know that for making animations, you do have to make certain bones. And then once the constraints are defined, you can do the animations. So not only can you generate the characters, but you can tweak the bone structure. You can create your own, regions of interest and do tweaking in the animation. And what it can do is it can also blend the generative AI animations and your manual animations both at the same time, and all of this takes seconds. Nothing months, nothing weeks, nothing days. This is text to high-end 3D animations again. A person jumps off a platform, jumps left to right. I'll run. It was very fast. I just wanted to keep a few seconds. Person skips in a circle. So all of this is text-based animations, directly usable. Just put it and put it into any game engine, text prompts based, and very human looking. There is nothing glitchy about it, and very whimsical. You can make but it will still be very human. And last, this was amazing. This company is taking huge crowdfunding right now, Opus AI. I'm not sure if you can read the text, but what it is doing is real time the sky was clear, it was a small road, it continued on the other side as it crossed the main road, forming an intersection with wet patches from the rain. The dense cluster of buildings forming the business district seemed deserted. On the right side of the road was a small cafe. There was a few tables. There were a few covered tables around. So it is editing while we are writing and creating 3D environments. So it is amazing, and you can create very creative and very whimsical environments. So it is not just for gameplay. I can make a lot of training environments, educational environments, and I don't have to focus on the background. I will be focusing only on the AI parts, on the parts where it really matters for the user interacting, physics is involved. I can put, so if I'm a one-person show, I have my own company, and I'm a coder in place, then I don't necessarily have to put in money or pull in a new resource or wait for or have to buy very expensive resources. I can use all of these for prototyping, great for prototyping for designers or for coders, but also end up using these also in the actual experiences now with the latest technology in place. So how else can generative AI help XR? Content creation, we already discussed. So not just 3D models, animations, but also textures, materials. All of these are very time consuming to create manually. Personalization. Generative AI can personalize XR experiences based on your preferences and behaviors, right? Not just about avatars, even the experiences can be when you say personalized, I like to have certain other kind of environment. Those can be made so quickly with generative AI, so we don't have to follow the same storyline in the experiences. It can be very customized in nature. Also, we always like to have on the, on the desktop, we have always assistant, somebody prompting, Google Assistant always prompting on the mobile. We are used to assistants. Why? Because we want things to be done quickly and effectively, right? Same way in virtual world, you tend to be lost a lot more, right? There are a lot of distractions. You can be in a completely different room and not finding what to do with that. Nothing is intractable, and the intractable things are in a different room. You want assistants to be always there, right? So virtual assistants can be very customized with generative AI. Now with generative AI, we cannot look back and think of how conversational AI was before. With ChatGPT, we know what it can be now. It cannot be like the banking virtual assistants, which has only n number of questions and it can answer only n number of questions, right? It has to be human. It has to have n number of possibilities and can answer me anything, right? So such things can be made possible only with generative AI. And real-time translations, of course, can be done. And with virtual, we know that XR is already being used in so many industries. These avatars can be almost like your well-being, your companions, your work assistants, everything, almost like your best friend, right? So they know you better than yourself. They can tell you when to take off the headset. Now it's enough, enough of screen time. What to do with your posture, what to do when, right? So those things can only be made possible with generative AI. Limitations, of course, is the limited creativity currently. With ChatGPT 4 and all, we cannot say that anymore actually. But bias remains. Limited applications also remains. Resource intensive, yes. You cannot have a very custom generative AI working completely on your own server if you do not have, you know, uh, you need to have a lot of resources for that. And of course, ethical concerns. What are these ethical concerns? This is what I want to end up this workshop with. With great power comes great responsibility. We already saw what generative AI can do, which means you can now populate your metaverse with n assets and it can really explode. And you are already seeing so many virtual games, experiences, trainings, retail shops, experience. All of this is coming up. But with the decentralization and accessibility of generative AI, immersive realism of XR, and with the immersive realism of XR, the content is so powerful that it affects the user very deeply. I want to take a case study here. A person in a multiplayer setting was playing a game. I would not name the game, but the game was very immersive, realistic in nature. And what happened was a person from a different country, almost like a terrorist attack, would zero in on this person, the victim, and would come and from nowhere he would come and would give, I don't know the term you guys use it, but headshot from a very close distance, right? Every time, multiple times. And this person actually developed PTSD, like symptoms. Ended up having certain vertigo and PTSD. So this is not very different from what you would actually face in a war-like scenario. And the kind of bullying that you see in colleges, schools can also happen in virtual worlds, right? Because this is very decentralized now. As it is exploding and the scale is increasing, anyone can use different, experiences to bully anyone, can be racist. And then there is a case study where certain trainings were being given by certain experts. They charged a lot. For example, you wanted to learn cricket and you paid that you would learn from in virtual reality from Sachin Tendulkar, and you are promised that Sachin Tendulkar's avatar, which is being remotely controlled or is trained by Sachin Tendulkar himself, will actually give you the training, but with deep fakes and the 3D, deep fakes in place. What if that is not Sachin and you end up paying for Sachin? This is all happening. This is not something that I'm making up. So, who bears the responsibility? Whether the ownership of the actions lies with the platforms, the creators, or the end users. You have to do, you have to save yourself. It is democratic because we actually currently do not have any kind of standardizations or moderations in place, not in development, not in the experience itself. There is one agency, Chronos, which is creating standardizations for multiple platforms. OpenGL, Vulkan, all is created by them. They are making a standard for development called OpenXR, right? All of the headsets these days are all OpenXR friendly, so that the development journey is very synchronized. Everything is cross-platform. Any experience that plays in one headset should also be playable in other headsets. So OpenXR is there, but moderation does not exist yet. Why? Because we feel it is not, has not reached the zenith of acceptance in general users. But there won't be a lot of time for us to do that if we don't start thinking on that right now. So can the cause also be the cure? Can I use generative AI itself to moderate AI-based experiences? Yes. We can flag the content that is made by generative AI. We can flag the content which is offensive in nature, and these are already done in certain experiences like VR chat and other things are there. But with Gen AI, it can be done even more. It can be really scaled to all experiences. It can be made almost like an OS service. In the OS itself, nothing can be done which is of offensive nature, right? Like somebody talked about, one of the students actually talked about the Meta's glasses recently launched, Meta Orion, which is a smart glass which captures, you can directly take videos on the go firsthand and live stream. But because they knew about the ethical concerns and already had a problem with Snapchat stories glasses, they now have to have a LED which always glows if you are being recorded. So the bystander knows that they are being recorded, right? And all of these things can be moderated by AI. So it will not allow you to stream somebody else's who has not consented to it. It will not allow somebody else to capture and utilize your personal space. If your home is being captured, then the platform and the OS itself should make it almost like location centric, that this data can only be made useful when you come in this space. Nobody else, even on the server, even me as a company, I cannot use it. It is not a personally identifiable data that I have on my servers, right? It is only understandable when you regenerate the space around you in the headset that you are using, right? So while there may be not be a single solution to address these challenges, I would be happy to discuss some suggested approaches and if there are any other questions. Thank you so much for your valuable time.
Any questions? Okay, thank you, Ms. Yukti Suri, for that insightful session on design.
Just nothing technical, because we have also been studying these things. One thing, like when we do with a lot of XRs, everything, what happens to the brain? Like we heard the lecture in the morning, load, the stress on brain.
Right.
So we have noticed this during COVID time, a lot of digital devices that we have used,
Right.
and we were more stressed than before.
Right.
And I have actually lost my eyes, dryness is because of that only.
Right.
Uh, so this is question number one, and I will give both the questions. And then you talked about 52 to 55 frames per second. It can go up to that somewhere I heard. Uh, I would like to know that if we move, like if we are making use of autonomous driving cars, how does it compare with those where you do not need to require like virtual real, because camera is already there. So how does it compare with that? Over to you.
So the first question is about the health impact of such XR devices.
Yeah.
I would say, there are certain pros and cons associated, but responsible companies who are making such XR devices do actually put a disclaimer that, children below 14 years and pregnant ladies in very virtually immersive environment should not be using such a headset. They can use it for AR experiences, see-through experiences, but not for very VR immersive experiences, you are blocked from your real surrounding. So those do come up in our, as soon as you start the headset, such disclaimers are there by most of the responsible companies. About the eye protection, these displays do have the displays right in front of the eyes. I cannot take away from that.